A giant squid's eye can grow to around 11 inches across, roughly the size of a basketball. That is larger than the head of most adult humans. It is the biggest eye of any animal that has ever been measured, living or extinct, and for a long time nobody could fully explain why an eye needed to get that big in the first place. The obvious guess is simple. Bigger eye, more light gathered, better vision in the dark. That's the assumption most people land on right away. But when scientists actually ran the numbers on how eyes work in deep, dark water, that explanation started to fall apart. An eye that size doesn't actually make a huge difference for regular vision once you're already past a certain point. So, if it's not about seeing better in general, what is an eye this massive actually built to do? Let's start with where this eye lives, because the environment matters more than almost anything else in this story. Giant squid spend most of their lives at depths of around 1,000 to 3,000 feet in water where sunlight from the surface barely reaches at all and past a certain depth disappears completely. Down there, almost the only light that exists comes from bioluminescence, small flashes and glows produced by other deep-sea animals, often as a defense reaction or simply as a byproduct of movement through the water. For years, the assumption was that a bigger eye simply meant a bigger light-collecting surface. The same basic idea behind why a bigger camera lens can capture more detail in low light. And that logic isn't wrong. Exactly, bigger eyes do gather more light. But researchers eventually noticed something strange when they modelled exactly how much extra benefit a giant squid actually gets from growing its eye larger and larger. Past a certain size, somewhere around a couple of inches across, the improvement in regular image sharpness barely increases at all. You keep adding size to the eye, and you keep paying a real biological cost for it, but the payoff for everyday vision essentially flattens out. So an eye 11 inches across should be a strange, wasteful investment if normal vision was the only goal. This is where the story shifts, and where the giant squid's biggest natural threat becomes the actual explanation. Giant squid share their deep, dark habitat with one of the ocean's most capable predators, the sperm whale. Sperm whales hunt using powerful sonar, but they also move with real force through the water, and that movement often disturbs the tiny organisms nearby, triggering small flashes of bioluminescent light as a kind of accidental side effect. A sperm whale approaching from a distance can end up surrounded by a faint shimmer of these disturbed light flashes long before it's anywhere close enough to actually strike. Researchers eventually proposed that the giant squid's massive eye isn't primarily built for everyday hunting or detailed vision at all. It's built specifically to detect these extremely faint, large-scale flashes from as far away as possible, giving the squid crucial extra seconds, or even minutes, of warning before a sperm whale gets within striking range. In the deep sea, where sunlight doesn't exist and everything runs on timing and distance, an early warning system like that can be the difference between escaping and becoming a meal for one of the ocean's most dangerous hunters. This explains something that didn't make sense under the old assumption. If the giant squid's huge eye was mainly about fine detail and sharp everyday vision, you'd expect other deep-sea predators facing similar darkness to also have developed extremely large eyes. Most of them haven't. Many deep-sea fish and other cephalopods living at similar depths have eyes that are proportionally much smaller. The difference lines up almost perfectly with which animals are being actively hunted by something huge enough to disturb the water and trigger those wide. Faint bioluminescent flashes from a distance. The giant squid isn't just living in the dark, it's living in the dark while being hunted by one of the largest predators on the planet, and that specific pressure appears to be exactly what pushed its eye size so far past anything else in the ocean. To understand just how strange this eye actually is, it helps to look at how it's built on the inside, not just how big it looks from the outside. Like a human eye, a giant squid's eye has a lens that focuses light onto a layer of light-sensitive cells at the back. But the giant squid's lens is proportionally massive and nearly spherical, shaped almost like a perfect marble rather than the flatter, more oval lens found in a human eye. This rounder shape is actually a very old, very effective design for gathering light underwater, and you'll find a similar shape in fish eyes as well, since water bends light differently than air does. The giant squid simply scaled that same basic underwater eye design up to an extreme degree, keeping the same efficient shape while making it dramatically larger than anything else using that design. Behind the lens, the layer of light-sensitive cells in a giant squid's eye is packed with structures built specifically to catch as many individual particles of light as possible, even single ones, in an environment where light is almost non-existent. Researchers studying the physics of vision in extremely low light conditions found that once an eye gets large enough, it isn't really limited by its own design anymore. It becomes limited by something much simpler: how few actual particles of light exist in the water to begin with. Past a certain size, adding more lens and more light collecting surface doesn't help you see finer detail, because there's no extra detail available in the available light to detect. What it does help with is detecting rare, brief flashes of light from much farther away, exactly the kind of large, faint bioluminescent shimmer a sperm whale might accidentally create while approaching from a distance. To understand why a smaller eye would fall short specifically for this job, imagine trying to notice a single, faint flash of light appear somewhere far off in a completely dark room. A small eye with a small lens and a small light-collecting surface might only pick up on that flash if it happens to occur relatively close by, or if it's bright enough to stand out clearly. A much larger eye, with far more surface area dedicated purely to gathering whatever scarce light is available, has a dramatically better chance of catching that same faint flash from much farther away. For an animal whose survival might depend on noticing a predator's approach from as far off as possible, that difference in detection range could be the entire reason it survives an encounter instead of becoming a meal. There's also a physical cost to growing an eye this large, and understanding that cost helps explain why this trait is so rare. A bigger eye needs more blood supply, more supporting tissue, and more of the animal's overall energy budget just to maintain it. Evolution doesn't build expensive structures like this without a strong reason. If the giant squid's oversized eye wasn't providing a real, meaningful survival benefit, natural selection would have trimmed it back down toward a more efficient, average size over enough generations. The fact that this extreme eye size has persisted and shows up consistently across giant squid populations is strong evidence that whatever benefit it's providing is significant enough to be worth that ongoing biological cost. It's also worth mentioning the giant squid's closest rival in this category, the colossal squid, which lives in the even colder, darker waters near Antarctica. Some estimates suggest colossal squid eyes may grow even larger than a giant squid's, potentially making them the biggest eyes in the entire animal kingdom once fully measured. Colossal squid share many of the same pressures as giant squid, living deep, living in darkness, and facing predation from sperm whales as well. The fact that a completely separate, closely related species facing a very similar set of survival pressures also developed an extremely oversized eye adds even more weight to the idea that this isn't some random oddity. It's a direct, repeatable response to living somewhere dark and dangerous at the same time. Put all of this together and the giant squid's enormous eye stops looking like an evolutionary accident or a strange leftover trait and starts looking like a very specific, very deliberate survival tool. It isn't there to help the squid see fine detail on a nearby fish or to make out sharp images of the seafloor. It's built to catch the faintest, most distant flicker of disturbed light in an environment with almost no light to begin with, buying the animal precious extra time against a predator it has almost no other way of detecting early enough to escape. So the next time you picture a giant squid drifting through the deep, don't just picture a strange, oversized sea creature. Picture an animal that evolved one of the most specialized early warning systems in the entire ocean, built directly into its own body. Simply because the alternative was running out of time the moment a sperm whale got too close.